So we want to welcome you to the Kentucky Center for Mathematics afternoon Zoom session. This week our focus is on geometry, and today we have Dr. Leah Dix-White. She is a regional consultant out of Louisville, and she is here to talk to us about geometry with technology tools. So I look forward to learning from you, Leah.
Hello, everyone. Welcome to today's session. I told myself I was going to talk slow and slow down, so if there are longer pauses than usual, this is a growth for me. So I'm hoping I won't talk so fast. But anyways, today, hi, I'm Leah Dix-White. I will be talking about geometry and technology tools. So here we go. As always, you can check out our information on our website. We have all of our sessions and the recordings of our sessions, resources, lots of good things for you to check out. So please do. And since most of us are familiar with that, I'm not telling you anything you don't already know. All righty, moving on. So today we are going to be talking a little bit about the Van Hiele model. And I know you've heard that from the presenters earlier this week. So I'll try not to be redundant with that, but I want to touch base on the particular levels 2 and 3. Those levels that students should be aiming towards in high school. And then we're going to address the standards for a task that I've selected. The task I got from the problems of the week from NCTM's problems of the week that they have. So I think it's going to be pretty cool. So we're going to look at this task, and then embedded within this task are 2 resources that I think are great for geometry, particularly for high school. And then I'll share some other resources with you, and then give you some information about multiplication next week. So the Van Hiele levels of geometric thinking. I know you've heard about this and we've had some great readings in reference to this, but today I want to talk about particularly level 2 and level 3, because these are the levels that students are at when they're doing geometry that's involved with high school geometry in particular. So it's the idea that we are able to make distinctions among properties, and we are able to make connections between those visuals that we see and make inferences about what they do with shapes that are similar or like those figures that we are looking at. So students have had lots of experiences with the prior levels if they are at level 2, actually. And so I know that you've heard about that with D, and so I have a little video clip where someone explains really well about that transition from 2 to 3, and we'll get to that. And then obviously you have level 3, which is really the level that most people reach. Most people don't go beyond that level. And actually at that level, you're able to distinguish between a postulate and a theorem, a conjecture. You're able to apply those properties to different figures in different situations, and you've had experiences with the prior levels in doing those same things. So that would be level 3, and then level 4 would be the highest level, obviously, and it's more so for mathematicians or math majors, and you look at other geometries that are non-Euclidean. And that was interesting to me because as a math major many moons ago, I didn't realize there was a geometry other than non-Euclidean. And so there actually is. And so that would be level 4. But I really want to talk about level 3, and that there was some research done, obviously, in the States after the Van Hiele model was developed years later in the late 70s, early 80s. And I've cited that research here with Berger and Shaughnessy. And they did a study where they were looking at how students transitioned in between levels. And I wanted to share this with you because I'm hoping that the task that I've selected today, that you will see some elements of level 3. And so I'll give you a moment to read over those without me talking, and then I'll share with you a small video clip that talks about transitioning between level 2 and 3. And so I found this interesting because it's this reliance upon proof as the final authority. And I know this study was done in the 80s, and then I was thinking, oh, how often do we see proofs in secondary geometry? It's usually just like a section or a subject. So I wanted to touch base on that a little bit and show you this brief video clip. I've had it queued up where the speaker, and she's an instructor, she's talking about transitioning from level 2 to level 3. So, whoop, let me go back. Let me see. I want the video.
Level 2, abstraction. The student understands that properties of shapes are related and that one set of properties may imply another property. For instance, if a square has a right angle, we can also say that the measure of its angle is 90 degrees. Students can recognize relationships between types of shapes and even use informal arguments to talk about why a square is a rectangle. For example, they do recognize that all squares are rectangles, but not all rectangles are square, and they may be able to discuss this. Activities to help your students transition from level 2 to level 3. Encourage your students to make and test conjectures or ideas. Is that true for all triangles or just equilateral ones? Help them determine the necessary and sufficient conditions for properties of different shapes. Why does a pentagram always have 5 sides? Does it have to be fat and puffy, or can it be dented in? Students can learn the technical language for shapes and their properties and use the language of informal deduction. All circles have a radius. Some triangles have a right angle. No circles have a right angle. If a square is 5 inches wide, then it's 5 inches tall. Encourage your students to attempt informal proofs and help them to engage in open-ended tasks such as this one. How many different polygons can you make on a geoboard with area 6? They can record their answers on geoboard paper or graph paper. Level 3 is deduction. Students at this level understand the role of undefined terms, definition of terms, axioms, and theorems in Euclidean geometry. However, they believe that these are fixed rather than arbitrary, and so they're not ready to deal with non-Euclidean geometries. Geometric ideals are still understood to be in the Euclidean plane. We'll learn more about non-Euclidean geometry in this class. Level 3 is the level of a high school geometry class. However, most students in high school are not ready to learn at this level. So if a teacher teaches at this level, the students may not be ready.
All right, so
Level 2,
let me minimize this.
abstraction.
Hold on just a
The
second.
student understands.
So if you could, in the chat, while I'm getting back to the PowerPoint, could you share with us or the group, why do you think it is that high school students are not ready, or what experiences are they lacking that's prohibiting them from being ready for level 3 in geometric thinking? What do you guys think? You can unmute or you can just type in the chat.
This is Dee. What we're not giving them in middle school is opportunities to do the informal deduction, so they're not ready for the formal deduction. We try to shortcut things by, there's a formula, so just plug and check it through, and they don't actually ever get a chance to see the relationships between all the different things in those shapes, so that they don't have basically the foundation to go to formal because they never got to do the informal.
Very true, very true. And that was what I was trying to get at when I was saying that, oh my gosh, this is level 3, but our kids aren't ready for level 3 because they don't have those experiences, particularly with the informal. Anyone else want to share?
I feel like this level 3 is where you start really producing stronger mathematical arguments. And when I say stronger mathematical arguments, it's not so different than an argument maybe in the literature where you have backup evidence, all that kind of stuff. But in mathematics, when you produce the arguments, you start with a definition sometimes. For example, the polygon example or pentagon example, there's a specific definition we use as our basis. And then we try to prove what shapes are polygon or pentagon or not by using that definition. And there comes all the axioms, theorems, and then the real mathematical proof-making process.
Nice. Thanks for sharing that.
In the chat, Sloan had something, this was good. Geometry is the last thing that's usually taught in lots of schools' units, and so they don't give it enough time. It feels rushed at the end, obviously.
That's very true. That's very true. So we see somewhat of the implications of that. A lot of students are in a high school geometry classroom as either a freshman or a sophomore and haven't had enough experiences with certain tasks, not enough experiences with that particular concept. And so then, as Berg and Shaughnessy said in their research, you find that students aren't as successful. And that's basically what we're all saying. So the standard that we're going to talk about in today's task, I wanted to find something where I could kind of incorporate some modeling because that's my favorite area to teach. And so I stumbled upon these two standards, and I put the whole sheet here because I thought it was great how in the KCAS standards they add these clarifications. And so I'm really was trying to reach these clarifications where students are practicing the modeling techniques within the standard. And so being able to apply geometric methods to design, I think, is a great application of being in that second to third level of the Van Hill geometric thinking. And so that's why I picked this task. And I wanted you to see how Kentucky had laid that out in the standards. And so I think it's really great. Now, there are other standards that are addressed in this task, but these are the two that I wanted to highlight. And definitely the mathematical practices, the modeling, MP4, MP6, attending to precision, those are key to today's task. All right, so let's get to the task. And I'll give you a chance to read it because it can be a little tricky, but I've cited the problem. It's a POW from NCTM. And so there are lots of entry points and lots of different ways to address this problem. And so in the handouts, I know in the chat that the handouts for the problem and the teacher notes are attached, and they also have the solution. So don't worry if we can't get to the solution by the end of this presentation. But I'll be quiet for a moment. I'll give you a chance to read the task, and then you can share your perceptions of the task or how you would go about starting it. And this is a Algebra 2 calculus type level task. So go for it. I'll be quiet. I know, tricky. So if we were to start this task, what would students need to know about prisms to respond? Or what would students need to know in general to respond? You can share out or share in the chat. Or what experiences would students need to have had prior to answering to this task?
To understand that, you know, rectangular prism is just a plain ordinary box, is one. You know, sometimes that's one of the harder objects to name because everybody wants to call it a box, and that, you know, the mathematical term that goes with it.
What about the properties of the prism, and what do you think students need to know? What terms need to know in order to be able to address this problem, do you think?
Just to clarify,
Girth?
Yeah, that's what I was going to ask. What does
Yes,
girth mean?
absolutely.
Yeah, I think girth is a word. Yeah. Thanks, Fiona, for being in my brain. Yeah, girth is a word that I think students would be like, what is that? Yeah.
Yes. So definitely, so girth, it would be the perimeter of the base of the box, or the square that makes the base of the box. So that's key to the problem. So that would definitely be some questions students might have. Anybody else want to share before we dive into a strategy in tackling this problem? Okay, so here we go. So I was thinking about this problem. I was like, students need experiences with rectangular prisms. They need to know what it means when we change dimensions. And so I put a QR code in here so you can scan to this. I didn't write or create this applet, but this is a GeoGebra applet. You've seen them this week. I thought it would be key for students to have this experiences with length, width, and height before tackling this problem. It would just have to be key. Maybe they would have those experiences in your class, but they would definitely have to have had it prior to, because I think in order to understand and really address the problem, you have to know what happens. And so I'm just going to share, wait, let me go back. And I want to just show you why I think this would be a good experience. One, we can change the dimensions here to, and I know my computer's running a little slow. I can change the dimensions to inches to match the problem so that it's in context. And then I can use these sliders to adjust, and then I don't necessarily know the volume, but I know that I can count the squares or determine the volume, and then I can determine what would be some good guesses as a box size that would meet the specifications of this problem. And so I think this is one of the experiences that would help enrich students, and I have some others that I'd like to share too, but I think that would be great exploration for students who have had prior to tackling this problem. So what would be a good entry point for kids? A guess and check. And so I want you to try and make sense of this table. If you were a student, an Algebra 2 student, you'd probably would want to do some type of guessing and checking. And I kind of created a table that shows that. So I was like, okay, maybe I can pick a package that has height and width 15. And now that I know what girth is, I can calculate that distance and determine lengths and see which volume would give me the highest number. So I kind of pretended like I was a student, and of course a student might not organize their information in a table like this, but I want to share that with you, that I think experiences with the prisms, I think students would be more likely to guess and check in this way. Although there is a very algebraic pre-calculus way of solving this problem, I think students would enter it this way, giving their understanding of how prisms work. And so just making guesses. And then what you would notice is that something happens between package C and D. The volume changes. And so that's given me some inferences about what the size really needs to be. And so then from there, I can use those inferences to make some more guesses. So these are the attributes that were discussed in the video, being able to transition between 2 and 3, being able to use some reasoning, using that deductive reasoning to make decisions in reference to the task. And so I think that's key there with the guess and check. Another thing I wanted to share with you in being able to guess and check is to being able to draw. And so I found a really cool resource that's available for free for teachers. It's called Sketchup for Schools. And I have embedded with the handouts a link that you won't be able to open until you access and sign up for the program. And it does require you to have a teacher email, but I think that it is a great program for high school kids and middle school kids because it's that whole drafting in 3 dimensions. And so I wanted to share with you really quickly the drawing that I created to address this problem. And so here, Sketchup for Schools, it's kind of like GeoGebra in that you can draw and you can create objects, but what I think is most unique is this right here. I can look at all views of any object that I create. And that's what's essential, right, in engineering and drafting. And so I think this is giving kids early experience with that. And even this drawing that I created was not very difficult to do. And so let me just show you how I would use this to make some guesses about box sizes. And so I clicked on this toolbar here to create a box. And so remember, I was experiencing with links with my guesses. Sorry, I moved. And so what I can do is create or draw a box, and I can have visuals of my guesses. And so you can draw a box of any size, and then you can specify the dimensions. If you can see here in that measurement box, if I specify the dimensions, it will make it that size. And so I can click here. If I click on the axis, of course, it's being kind of quirky today. Let me see if I can get this. So if I click here, I should be able to put in the dimensions. Hold on just a second. Okay, so it's being a little quirky for me, but you can input the dimensions for anything that you create. I just have like a slight delay on my computer that's not allowing me to do that, but it will allow you to do that. Another thing that you can do is this pull-up tool, which I thought was really neat. I can click on a shape and pull up vertically here and draw the solid in that way. So from there, I could measure all of these distances here. That's how I got my measurements. So this is perfect for drafting, right? And I can then manipulate these pieces if I need to. I can move in and out. And I think even though it is like learning a new software, I think our kids can do this kind of stuff, especially in this virtual setting we have now. So I just wanted to share that with you. Even though drawing the packages doesn't get you to the solution of the problem, I think there's something key about drawing and having something to actually draw and to manipulate. And so I wanted to share that with you guys.
Leah,
So that
if
is
you don't mind,
SketchUp.
I don't mind to tell you that my boys, they're both grown and math. One was a math major in college, the other one's an engineer now, and they loved using SketchUp in high school. They did that in their free time. So kids can do it way easier than we can learn it as adults, just because they're so tech savvy. But it's easy for them.
Right.
For me.
I just think that's part of the experiences that we can provide for kids that help them with their geometric thinking. Just being dynamic and being able to manipulate it. It helps you understand the properties of whatever figure you're manipulating, and also helps you with that transition from 2 dimensions to 3 dimensions. So I think that's key. As far as like working out the solution to the problem, the easiest path would be writing expressions and using algebra to create an equation and then calculating the derivative to maximize the area. But that's just one way you could respond to the question. And so for the maximum volume, I think the dimensions would need to be 16.5 by 16.5, and the height would need to be 33 1/3. And you would have gotten that from those calculations. But you could have also gotten there from guessing and checking and drawing the pictures and calculating different volumes and making those reasonings from when the volumes drop when I changed my height and weight from 17 to 18. So those are some things I think that we can put our kids in positions to do, and that will help them progress along those levels of understanding. And so also in the handout, there are some questions that would help students when they don't respond correctly to the task. So questions about girth. Did you remember that the combined length with the girth could exceed 100? Did you draw a picture? Did you remember that the base had to be square? So there are other questions that you can help kids move them along as they're going through a task like this, but I thought that those 2 technology tools would definitely help with their geometric thinking and their understanding. Other virtual resources or any comments about the task, the technology Van Hill level and understanding anything you all want to talk about at this point.
I had always said that awesome power of what if, and the technology tools really allow that to come to life. So always good for kids to think what if and use the table to organize their information and the technology tools to really get to the mathematics.
Nice, thanks. Yeah, I just saw D type that in, but yeah, Sketchup is free through July. I think it's just get in there and just play around, and maybe it's something that, you know, you can get into, especially if you teach geometry in middle or high, or even smaller than that. So those are some other virtual resources that are worth checking out. You've seen them this week. Desmos, GeoGebra, and of course Sketchup. And as always, you can follow us and check out our information on our website. Thank you so much, guys. Thank you for being attentive and for listening on this Friday afternoon.
So this is the time when we thank Leah for kind of her leadership on this. Looking in the chat box, we see that Rachel says, thanks for those great resources, and we really do appreciate our elementary friends for going through the journey with us this week with regards to geometry, because I certainly, you know, today was the culmination of thinking about how it all builds together, and they cannot get to something complex and the real essence of how mathematics can help them without that journey. We'd love to hear your voices, and so maybe a couple folks unmute and give us some feedback.
I would just say that as a primary teacher, this gives some insight as to where our children are headed or what they need to work towards. So when we're teaching geometry class and it doesn't get as much attention, excuse me, we can just see how this is going to hurt them in the long run.
That's exactly what I was typing out. It's important to know you've got to make that time to get that geometry unit covered.
Absolutely, and based on Dee reminding us yesterday about how many of the standards for 7th and 8th grade mathematics happen to be geometric in their kind of foundation. So important that kids have those opportunities to touch and to think about it so that they can problem solve with it at the high school level. Indeed.
And for those of you that weren't here yesterday, there are 14 geometry standards in 7th and 8th grade. 14. They can't be shortcutted.
No. And they're so interconnected, and they're so foundational to what they do at the high school. Leah's background is that she's a geometry teacher by trade and really enjoys and loves that subject and gets just how important it is to lay the foundation in elementary and middle.
You know, this made me think about the activity that Bonnie did with the cubes.
Yes.
And how she built that up into the PVC pipe.
Yep.
An activity like that could really be beneficial to lead up to what Leah was just covering.
Mm-hmm, mm-hmm. I used to have a question where students were making different kinds of juice boxes based on some given parameters, and unleashing those students to think about the situation and how we might be able to make those juice boxes. So important that kids have that opportunity to problem solve and to think about it. I do have to say, as a side note, one of my son's best friends is a packaging engineer. He went to Michigan State and his degree is in packaging engineering. Why? Because we all buy stuff in a package. That's exactly right. So he has and Bonnie's right, visualization is huge. So we want to thank you. Again, you can see why you want to hang with us at the Kentucky Center for Mathematics. Our trajectory is to take you from the beginning to the end and see how it's all connected. So we thank you for this Friday afternoon. Appreciate Leah's leadership with this. And we'll see you guys on Monday for more multiplicative thinking. I had to think about what that was. Monday's more multiplicative thinking, and we have Bonnie on tap for Monday. Thank you. Happy Friday.